Hi.
Hi, everyone.
Thanks for having us here. So I'm Nicolas, he's Bachir, and today we would like to talk about leveraging blockchain technology in order to deploy reinforcement learning trading agents. So I'm Nicolas, I'm CEO at Miril.io. Before that, I was a PhD student in machine learning, especially reinforcement learning. And then I did a postdoctoral studies at the University of Toronto in the same domain.
So my name is Bachir Arif. I'm the CTO of Miril.io. I have a good background as an engineer, especially in blockchain area. I work for Deloitte and Luxembourg Institute of Science and Technology on it. And today I will explain a little bit what is blockchain. So what is a blockchain? Blockchain is distributed transactional database. It's appeared with the Bitcoin in 2008. The key concept behind the Bitcoin, and it allows people to transfer and transact cryptocurrencies. So to do that, what the process to interact with the blockchain infrastructure is someone create a transaction and request it to a node. A node is only a computer who is running a program, a protocol. If we take an example, Bitcoin is a node who is running the Bitcoin protocol. So the node receives this transaction and broadcasts to the network. The network is managing between each other. After the broadcast, the network should validate this transaction using cryptography tools. After that, they're gathering this transaction with other and create a block. And this block is mined and it will be attached to other blocks. This is why we are talking about blockchain. Blockchain is only a chain of blocks. And inside each block, we have many transactions. So this is the overview of what is a blockchain. And another key concept is coming with the blockchain infrastructure is the concept of smart contract. What is a smart contract? A smart contract is only a computer programs executing some rules. I will take an example with a contract. Anyone knows what is a contract currently? A contract is a paper who describe some rules or some interaction between peoples, humans, or objects, and there are actors around the life cycle of this contract. Of the auditors who manually or semi-manually gathering data and collect data and see if the contract is well executed, or other if the contract was not well executed, like people like who are give his opinion about an event, a wrong event. Smart contract coming and automated all this process. So now a contract is a software program automatically executed on the blockchain or a secure environment. And for the audit, everything is contained on the blockchain thanks to the transaction and the blocks. So everything is transparent for people. With this, we saw some standards coming, and the standards is just a representation of a physical assets. And I will talk about two standards. The first one is fungible token standards, or I will take an example. In Ethereum blockchain, we have the standard ERC20, who is explain and describe how people can create cryptocurrency. Dogecoin is one of the implementation of these standards. The other one standards is well known, and many people talk about it now, is about the non-fungible token, NFT. NFT is just a non-fungible token. So it means it's a unique tokens represent an assets. By example, I give you here an example of an NFT from the collection of Crypto Punk, and two other one from our platform. Based on these many assets, people create a trade between these assets, and we have some companies created some exchange. I will talk about two kinds of exchange. The centralized exchange is only online trading platform, allow buyer and seller to trade assets. This centralized exchange is Binance or Coinbase, to take only a small example. And the key criteria behind this centralized exchange is the availability of the high liquidity. Why? Because when someone would like to trade, the high liquidity is the measure, or it's described the ability to sell or buy very easily and quickly an assets. And for a trader, or for someone who would like to buy and exchange very fastly an assets, it's very important. The other exchange, the other kind of exchange is the decentralized exchange, or DEX. What is a DEX? A DEX is only a smart contract representing an autonomous financial protocol. It's the same as a centralized autonomous. What is the key behind the key criteria behind this kind of decentralized exchange? It is the ability to have the control of our fund. Because, as I said before, when we are using a centralized exchange, you put your money to a company, and this company holds your crypto or your currency. But with the exchange, and it's more aligned with the key concept of blockchain philosophy, anyone get the control of his money, of his fund. I will give you two kinds of decentralized exchange: is PancakeSwap or Uniswap. So thanks to this platform, many people in the crypto world and try to be a crypto trader. And just to explain quickly what is a trading, a manual trading is a human, a people like me, getting some information from the world, analyze the chart of an assets, and thanks to the information, I will take an action, and this action is to buy or sell these assets. And where I will buy or sell these assets, it's through an exchange. I put a standard exchange, or on all the exchange like New York Stock Exchange, or a new one, Coinbase or PancakeSwap.
Okay, and so so you can trade manually, but you are subject to your own emotion and to psychological biases, and also you have to be awake, right, to trade. You have to be on your computer, and so one way to avoid that is to create automated strategies. So you create automatic trading system. So we call the system a bot for short, and we as at Miracle.io, we call it a Myrmidon, or an agent. And so this agent gets the information of the world and pick a decision, so buy or sell an asset, right? The thing is, usually when people design bots, it's just about an algorithm with a set of intricate rules, like if this technical indicator goes up, I buy, or if it goes down, I sell, something like that. Those are very simple strategies, and they are not really optimized to maximize your return. And so the choice we made here is to use a framework called reinforcement learning. And so reinforcement learning is just a mathematical framework to describe an agent interacting with an environment. So the agent, it will pick an action. the environment will react to this action, and you can observe what is going on with the environment given this action. And so with this observation, the agent will update state, right? Its view of the world and its view of itself. And it will also get a reward with a value, and this reward will dictate how the agent create its strategy. So it will try to maximize the amount of reward it will get from the environment. And so behind reinforcement learning, there is a framework called Markov decision process. And so I will keep it simple with not a lot of mathematics, actually, so everyone can follow. So an MDP is a tuple with so the state space. So this is all the states the agent can be in. You have the action space, or the action the agent can choose. The transition function will describe how the agent move from a state, an action, to another state. Okay, and the reward function will describe how the agent is reward when he is in a state and he pick an action. And the gamma, we don't need to talk about it here. So the objective of an MDP is to solve it, right? And solving an MDP means finding a policy that will map states to action. So it's a function that will say, if I am in this state, I have to pick this action in order to maximize the cumulative sum of rewards. And this sum, we call it the return. So usually MDP are not deterministic. That means the transition function can be stochastic. And so to maximize the expected cumulative sum of reward, so the expected return, okay? And so this is an MDP, right? A simple representation of an MDP. So let's say your agent is here in S2 and he decides to take this action, A1. So there is 30% chance it will move from S2 to, right, S0, okay? And along the way, it will get -1 reward. So the transition function will dictate how the agent move from a state and an action to the next state. And the reward function will describe what is the reward the agent gets along the way. Okay, so here you have a simple example of an MDP. So it's called a grid wall. In this grid wall, the idea is to have an agent that is supposed to reach the goal. So you have the agent in top left, and you want to reach the goal in bottom right. And so the states in that case, those are the coordinates of the agent. So XY, you start in 0, 0. The action, you can go top, right, left, bottom, or even stay on the cell. The reward, so each time the agent moves, he gets -1 reward. But when you reach the goal, he gets +100 reward. And so the transition function, this time is deterministic. Basically, if you are in XY and you decide to turn right, you will be in X +1 and Y. If you decide to stay, you will be in XY because the coordinate doesn't change, right? Okay, so how to solve this MDP? So one classical algorithm is called value iteration. So the idea is to find the value of your strategy in each of the cells. And so in order to find this value, you have to iterate. So you will start finding the value for each cell at step 1, and then you will iterate on this to find the value at step 2. So, and you will repeat this process until convergence. So how does it work exactly? So you start with zeros. You put 0 in every cells, and then you want to compute the value. So what is the value in those cells? So the value here is 0. Why? Because if you move, you will get -1. But if you stay, you will get 0. So the best strategy is to stay, right? If you are here, so the best action is to go right. Why? Because if you are going right, you get -1 because you are moving, but you get +100 because you are ending up in the goal state, in the goal cell. And so you will get 99. But if you go left, you will get -1, but you will only get 0 in the next cell. So you get -1. So because 99 is greater than -1, you decide to go right. Okay? So you can do the same analysis with the other state. And so you decide this time to go but, and you see that the value of the state is 91, and the value of the state is 91. So this is the first step of the iteration. But we do another iteration. So we do again, and realize that the value here doesn't change, but the value here changed, because you see, you move to but, you get 99, but -1, because you are moving. And so you keep doing that, okay, until you reach the starting point. And when you reach the starting point, so you want to compute the value in this state. So we do it again, right? We say if I move to the right, I get -1 plus 92. So in total, I get 91. If I go but, I get 90. So I get 89. And so what is the best action to take in this state? In this cell, it's to go right, because 91 is greater than 89. So you see, the value in this state is now 91, right? And you can extract now the policy, right? So you see that you have to turn right until you reach the left part, the right part, and then you go bottom. So this is your function that describes the strategy of the agents. And as a human, you can easily see that this is the best strategy, because basically you are penalized for each movement you are doing on the maze. So you want to find the shortest path to the goal. And obviously, this is the shortest path, because here you are doing a small, right? A small path that is taking 3 cells instead of taking just 1 cell. And so the algorithm is able to find it automatically. So this is the easy version of reinforcement learning, right? Of MDPs. But now how to apply, how to bridge between MDP and reinforcement learning. So basically, reinforcement learning is you take an MDP and you don't know the reward function and you don't know the transition function. This is what happened in most of the real world case, right? So in order to find the best policy, you need data. And in order to get data, you want your agent to interact with the world. So it will interact by trial and error. It will try an action and it will see the reward and it will see the next state. And so this information, this data, is called a sample. So you are in state S, you pick the action A, you go in state S prime, and you get the reward R prime. So here, for example, on this grid world, you start in 5, 3, right? So here, you go to the right, and you see that you end up here because the transition function is deterministic, and you get a reward of 100. And so about reinforcement learning breakthrough in AI, we have a lot. So those are most of the companies that did this breakthrough, mostly thanks and INRIA and Berkeley. So the first one, the biggest one, is DQN, so deep Q learning. So it's reinforcement learning with neural networks, basically. And they managed to solve most of the Atari game, right? And it was the first reinforcement algorithm that was using just the screen, so just the pixels of the screen in order to take a decision. Then we got AlphaGo, so also from DeepMind. They beat the world champion of Go, OpenAI 5, who beats the world champion of Dota 2, so a video game. Then AlphaZero, they beat the world champion of StarCraft 2 in 2019. Then the Rubik's Cube. So OpenAI managed robotics in order to solve the Rubik's Cube. And so the breakthrough here is not the solving of the Rubik's Cube. It's easy to solve the Rubik's Cube. The breakthrough here is the manipulation of the robotic arm. And finally, agent 57. So it's DQN plus a lot of improvements. And this agent was able to human performances on Atari, on all the games, and especially Montumeza Revenge, which is really hard to solve, they did it. And also from DeepMind. And until 2021, we just got improvement and some open source benchmark and stuff like that. So what about real-world application of reinforcement learning? So to start, let's talk about active research areas that could be applied in the next 2 to 10 years. So traffic signal control, some stuff I did at the University of Toronto, where you try to optimize all the intersection of, let's say, Toronto, and you want each intersection is an agent, and they have to collaborate between each other in order to create green wave and maximize the throughput of the cars. You can also do dialogue systems. So typically, Siri is answering you some stuff when you're asking him a question. Well, the brain behind Siri could be reinforcement learning. Right now, it's not. It's just rules made by thousands of people, but it could be reinforcement learning, right? And of course, robotics. In production, we already have a reinforcement learning system, for example, in medicine. So this is a very simple way version of reinforcement learning. You just have one state, and you want to decide which is the best medicine drug to give to a patient. So you will try drugs. So each drug is an action, and the reward is the patient is living or not, right? You have this bandit also in online advertising. Each arm is an advertisement, and the agent is supposed to optimize which advertisement is best for the user who is on the website. Has created an algorithm in order to cool the data centers of Google, and I know that Huawei is doing that also in the background. And finally, autonomous driving. So it's a bit tricky because you don't want to have a crash to get negative reward and stuff. But Wavy.io managed, so it's a London startup, they managed to create a car that is only ruled by a reinforcement learning policy. And finally, you can do trading. So reinforcement learning trading in production is Aiden. So it's just an advisor, right? It tells you, yeah, pick this action and you will maximize your net profit. But it doesn't take the action in your place. And finally, what we are doing, so Mirai.io. So when you want to do reinforcement learning and trading, you have to define what is my state, what is my action, what is my reward, etc. And so the state, in that case, it can be there are a bunch of technical indicators, right? You can have the moving average, convergence, divergence, the balance of your lot, so how much money I have to trade, all the pending order, all the cancel order, what is going on the market, what is the market sentiment. So I can look at Twitter, see if people tweet a lot about Bitcoin. That means maybe Bitcoin will go high or will go down. And so all those stuff is information the agent can use in order to pick the best decision. So the decision, it's an action. So it can be long, short, close, wait, do nothing, close a position. It can be just you can separate the action into small action, like I want to buy X% of my balance, or I want to buy with all my balance, stuff like that, right? And the reward, so it's quite easy in trading. The reward, you can just give the net worth of the agent, so how much money you make. You can also use a Sharpe ratio, so it's a mix between the net worth and the variance of the strategy. And finally, the transition function. And so the transition function will describe the market dynamics. So how does the market move? How does my agent also move? What is the change on its balance and stuff like that? Okay, so finally, last slide. So what we exactly do, so mixing blockchain and trading and reinforcement learning. So basically, the use cases, you are a human, you are using our platform, and you want to create a bot that is using Bitcoin and using Twitter data in order to take a decision, and the frequency of the trade is 1 trade a day. Okay, so you go to the Mirai platform, so it's a no-code AutoML / RL platform, and thanks to the platform, you can design the bot, train the bot, evaluate the bot, and so it will return you the parameter of the bot. So in that case, it's a neural network because it's a very complicated thing, right? And we can use this parameter in order to test the bot, to see the performances of the bot in simulation and even in live trading. And that way, we are able to certify the performances of this bot, and we can register these performances on the blockchain. And this registration is associated to an NFT, and also the parameter of the bot is associated to an NFT. Meaning you will create an NFT, and this NFT is your bot, and then all the track record of the bot, right? And so with this bot, you can use it, right? Do proprietary trading, or you can do copy trading. So people will copy what your bot is doing, and you can get fees along the way. And finally, you can sell it on the marketplace. So you can already buy a pre-sales bot right now. I'm so sorry for the advertisement. And anyway, at the end, the bot is still learning, even in production, because it is powered by reinforcement learning, right? So the more data it gathers, the more optimal will be the strategy. Well, thank you for your attention.